is Chapter 13, Problem number 27. How much energy is required to move a 1,000 kilogram object from the Earth's surface to an altitude twice the Earth's radius? In order to do this problem, you're going to want to write down the givens. So the mass of the projectile, which will be represented by little m, is 1,000 kilograms. Gravity on Earth, which will be just g, 9.80 meters per second squared. And the radius of Earth, which will just be little r, is 6.37 times 10 to the 6 meters. I also want to look at the equations that the book gives us, which the first one is potential energy. U equals negative g, big M times little m over r. And then gravity equals gm over r squared. So, start with the first equation. U equals negative g mm over r. Now, the change in u, it will be negative g mm over 3r, because you got to remember, the object is being thrown twice the radius, so that's 2r, and then you got to remember to add the radius of Earth, which is another r, so that's 3 r's, 3 radiuses of Earth, and then just the standard equation. So it's the negative g mm over 3r minus another negative g mm over r, and then that'll obviously be a plus. So we simplify it a little bit. We get negative g mm times 1 over 3r minus 1 over r, simplified a little further. And we get g mm over times 2/3 2 over 3r, sorry. And from before, from the equation up here, g equals g m over r squared, we can simplify that into gm equals gr squared. This is here, so we can substitute this in for that, which I did here. So now the change in u is equal to gr squared times m times 2 over 3r. And then you can cross out squared and the r. From down here you can simplify it. So now we get grm times 2/3 is the change in energy. Now we just plug in our values, our givens. So 2/3 times little m, which is 1,000 kilograms, times g, which is 9.8 meters per second squared, times r, which equals 6.37 times 10 to the 6th meters. And then that should give you the answer of 4.17 times 10 to the 10th joules.